So question 3a. First I'm going to read out the question. A particle starts from rest and accelerates as shown in figure P2.20. Determine A, the particle's speed at t is equal to 10.0 seconds and at t is equal to 20.0 seconds, and the distance traveled in the first 20 seconds. So I'm sure you've seen the figure, but let me just redraw it so that we can refer to it in our calculations. So we're being given I'm going to use black. So we're being given a figure like this. We have our 0, we have got our 1, we have got our 2, we have got our 1, we have got our 2, we have got our 3, and these are our negatives. Then we have got our 5, we have got our 10, we have got our 15, and we have got our 20 t in seconds, and this is our acceleration in meters per second squared. So then we are having, now I'm going to use red. So now the one in red, that's our motion, but then remember that's acceleration. Oh no, let me write this. So it's going all the way up to 10. Do not mind this here. It's going all the way up to 10. It goes at 15 where there is 0 acceleration, but there is velocity definitely. Goes to 3 and then to 20. So this is our motion of the vehicle, this one here. Let me just shade it. Since we've drawn our graph, now we're going to start with the questions. Question A. The particle speed at t is equal to 10 seconds and at t is equal to 20 seconds. So now at t is equal to 10. So A at t is equal to 10 seconds. We can use the formula for, and since we've been given acceleration, we can say acceleration is equal to final velocity minus initial velocity over time. Then when you cross multiply, you're going to have at is equal to v minus u, and that's final, minus initial. Then when you take the u side, you're going to have v being equal to u a t. I'm sure you're familiar with this equation, and then this equation is usually given in the question paper for physics PHY 101, that is. So now at time is equal to, at t is equal to 10 seconds, you're going to have your velocity being equal to your initial velocity is 0, because from here we've been told it's starting from rest, so it's 0. Then your at, your acceleration in this case is 2 according to the graph. According to the graph it's 2, and then your time is 10. So then your velocity will be equal to 20 meters per second. Then we go to at t is equal to 20 seconds. So at t is equal to 20 seconds, that's at time is equal to 20 seconds there. We can find it by in this situation we don't know our initial and we also don't know our final, so you can find the acceleration as the velocity as the area under this curve. So now we're going to say velocity is equal to base times height. So now the velocity is equal to the base is from 5 to 20, that's 5. Then the height is -3. Then the velocity is equal to -15 meters per second. Then remember, we can actually use the same formula for the part in A, where we can say the velocity is equal to the base times the height. The velocity is equal to our base in this case is 10, then our height is 2, So it still comes back to the same 20 meters per second. So when we go to the B part of the question, when it says the distance traveled in the first 20 seconds. So B, for this one we can utilize the speed time graph. So we're going to draw our velocity time graph. We're going to say 10, 5, 10, 15. This one can go on 20. So now this is 5 by the way. So we can now start analyzing our motion. So for the first 20 seconds it started from 0 and then it accelerated it accelerated until 20 meters per second. For the first 10 seconds we've been told it accelerated to 20 meters per second. So this is our velocity by the way. So this is 20, and then from 10 to 15 it had no acceleration. Acceleration was 0 there from 10 to 15. So then we're going to have constant velocity. The velocity was constant. Then from 15 to 20 it dropped from let me see up to 20. Being told it dropped to 15. It dropped by 15, dropped by 15. The velocity dropped by 15, so we're going to have it being over there. Then we're going to have this as our -5. Then that's where the motion is ending. So then we're going to find the area for this one. So we have got these shapes. So we're going to find the area for this triangle, the area for this rectangle, the area for this triangle, and also now the area for this square here. Let me just put these in black so that you can see them. So now we're going to have the area for this. Yeah, so now these are our shapes. So we're going to have the first distance here is going to be given by, let me put this as x1 is equal to half base times height. So now x1 is going to be equal to 1 over 2. The base here is 10, the height is 20, so this brings us to 100. So x1 is equal to 100. X2 is equal to this one, that will be L times B, the length times the breadth. So that will be, here we've got our 5, then the height is 20. X2 is equal to 100 again. How is it 100 again? Anyway, x3 is going to be equal to the triangle that's there. This triangle there has got a base of first 1 over 2, a base of 5, and then the height is, and then this was supposed to be there by 5. So then the height for this one is 15. Then its base is 5. So x3 is going to be equal to 15 by 5, that's 75. Then the half of 75 is 37.5. Then we go to our x4. X4 is equal to the square there, so that's L times B, which is 5 by 5, which is equal to 25. So then our x total is equal to x1 plus x2 plus x3 plus x4. So then our x total is going to be given by, we're going to get a calculator. We're going to add 100 plus 100 plus 37.5 plus 25. So now we're having our answer to be 262.5 meters. So that's it for question 3. We go to question 4 now.